And in this presentation, I will tell you a bit about why most AI agents are broken and how we can fix them. Okay. A brief information about myself. I'm a senior developer relations engineer at deepset. I have this technical background. I worked as a software engineer before, and for the last 3.5 years, I'm learning how to build with AI and teaching my learnings with people through talks and tutorials. And if you're a social media user, I share some of the things that I learned on social media, so you can find me on Twitter, or we can also connect on LinkedIn. And a little context about the company I work for, deepset. So deepset is around since 2018, and for the last 8 years, we have been solving some custom AI challenges from big organizations like Airbus, Siemens, Bosch, but also public sector like European Commission and some federal ministries in Germany. And now, quick show of hands from you, and I want to learn like your AI journey. So how many of you have deployed any AI agents into production? Okay, like I see 10, 12 hands. How many of you are experimenting or like still in the building process? Okay, I would say like 20, maybe 25. How many of you thinks that now AI agents are not reliable, I'm never gonna push them into production? Who thinks that? Okay, I want to have a conversation with you later on. But I kind of agree. Anyway, so let's talk about what these AI agents are. I mean, agents term is a relatively old term, so it didn't come up with generative AI, but it had a different meaning back then. Now it means an LLM-based system or LLM-based system that autonomously pursues a goal by interacting with its environment using tools. So you see 3 underlying items there. It needs to be LLM-based. So this can be a large language model, but at the same time it can be a vision language model. Maybe if you want your agent to understand some other modalities than text, for example. And it needs to be interacting with the environment. So it needs to be able to take actions through the tools that it has access to and change the environment and observe those changes and take relevant actions on top of that. So basically you have the LLM as the brain and you have the tools and you basically do some stuff. That's the gist. But why these AI agents fail majority of the time? Or maybe they are more stable right now, but what changed? Let's see why. So this is a quote from a community member of Haystack, an open source tool that I work for. And it goes like, agent involves a lot more work than expected, and 90% of it's pure engineering. Nothing really to do with LLM, but it's how to blend LLM into an agentic workflow that makes sense. And I 100% agree with this quote. Although we have like these very shiny language models coming up every day, like Anthropic releases like coming from Claude models, Gemini models, there was like Gemma 4 recent release. I don't even remember like the latest OpenAI like GPT model that is out there right now. Yes, like these are very capable models, but in the end, it is still engineering. And when we are building AI systems, you still need to act as an engineer. And like the LLM is like the 10% of what we are pushing out with the system, and the other stuff that we build around the LLM is much more important. And this is one of the reasons why, maybe the first reason why these AI agents fail, because we trust too much on the LLM, but we don't worry enough about the design that we have. So for example, we have brittle prompts. We have too many tools, especially with the MCP servers. Maybe we provide the whole MCP server to our agent and expect that it needs to solve the user query, but I mean, you already fill up the whole context with the MCP tool definitions. Or we don't have any fallback plans, so we have no idea what we're gonna do if the system fails and what happens then. And we don't do observability. And maybe we do some sort of observability, but we don't observe exactly what's happening inside our agentic system. So we have no idea about the agent about the agent tools, agent results, and what's happening there. And the worst one is no guardrails. So we are missing some safety and validation checks. So especially if you're working in a highly regulated environment like healthcare, or if you have an agent for your customer-facing application, then you need to be extra careful with the guardrails. And the failure reason too is the wrong use case. I know like agent is a fancy term, and maybe marketing comes to you and says like, oh, we need to work, like do something with the agents. But maybe this is not a suitable use case for you. Of course, if you have a complex multi-system problems requiring diverse actions, or if your task involves multiple tools and sources, like maybe you want to build a deep research agent, yes, agent architecture is a suitable architecture for you. So basically, if the goals are clear, but the optimal path to achieve them is not predetermined, yes, then you should go with an agent. But maybe AI pipeline or AI workflow is enough for you. Maybe you don't need anything more than that, especially if interactions for your use case can follow a predictable pattern like question answering or RAG, or tasks can be decomposed into clear steps like data ingestion pipelines. You know, like I have documents, I convert them, I pre-process them, and I create like embeddings and I put them into my database. So this is pretty predefined, so why would I need an agent for that? So if you prioritize stability, robustness, and efficiency over the automation potential of your whole system, then instead of an AI agent, you should go with an AI workflow or a pipeline. So basically, agents for reasoning and pipelines for defined flow. But it's not black or white. So it's a spectrum. So you can find the optimal level of autonomy between AI workflows and agents. Yes, with the agent, you have like high autonomy. You are able to now solve complex problems, but at the same time, you introduce high risk. But if you blend the two, you can control the performance of your system, but at the same time, you can have higher speed and also save on the costs as well. All right, now we have seen some of the reasons why AI agents fail. Let's see how we can design reliable agents. So for that, there will be some tools that I'm going to show you, and the first one is Haystack. Haystack is an open source AI orchestration framework by deepset, and it's also the backbone of our enterprise platform. It provides the tools that you need to build real-world agentic AI systems with visibility control and modularity. And there are some building blocks in Haystack. So one of them is component. Component is the smallest unit, and it usually has one job, like it's a retriever component or an embedding component that creates embeddings for you. Or a component can be for text generation. And by connecting these components to each other, you create pipelines, and pipelines are the graphs, and they are quite flexible. So you can even create your agentic loop with the pipeline if you want to create an agent. But if you are not very fond of components or pipelines, you can directly use the agent component that we have. This agent component is a special component, so it has a pipeline running, but we handle all the logic for you. So all you need to provide to this component, this agent component, is a language model. It can be from OpenAI, Anthropic, Google, or maybe other open models that you want to host on-prem or locally on your computer. Then you provide a system prompt to define how you want your agent to behave. And then you need to provide a list of tools. And these tools can be Python functions, external APIs, other Haystack components or pipelines, or MCP servers. And basically, all you need to do then, there is like a user request coming, your agent, by using the tools at its disposal, generates an answer for you. All right, now I want to show you a demo on about an agent that we implemented. So basically, we implemented this itinerary agent, by following some of the principles that we think that is important to build reliable agents. And it's a multi-agent travel itinerary planning system that creates a comprehensive travel plans for you with accommodation optimization and detailed daily itineraries. For orchestration, it uses Haystack, and it is connected to 3 MCP servers: Perplexity, Google Maps, and there's also one we have custom that's called Optimal Route. And as the model, so as the brain of the whole system, we are using OpenAI GPT-5 Mini. For the deployment of it, we use Hayhooks. Hayhooks is the REST API layer for Haystack applications. And for the UI, we use OpenWeb UI. So basically, if you're also using Hayhooks, you can deploy your application as an OpenAI API compatible endpoint, so you can easily connect it to OpenWeb UI. And it also has guardrails, streaming, and observability. And this is the agent architecture. So basically, there's a user query coming. It says like, oh, plan a 2-day weekend trip to Barcelona, focusing on architecture and tapas, basically a very, very detailed prompt. And then the system first does a validation. So it checks if this is relevant to travel at all. So because it's not like ChatGPT, so it's not a general purpose chatbot, it needs to, the query coming from the user should be relevant for the purpose of this agent. So it does this check. If it's safe, if it's relevant, then it passes to the agent pad. But if it's not, then it says like, oh, I apologize, but I cannot process this request. And then in the agent part, so maybe I can move my cursor, so in the agent part, this is the macro itinerary agent that is, you can think this as like the main agent. And there are sub-agents running. One of them is responsible for optimizing the accommodation strategy. So basically finding relevant accommodations if it's like a multi-day trip. And the other one is planning the daily itinerary. So basically what you should be doing in the morning, in the afternoon, maybe like where you should be going for dinner, etc. And there are some MCP tools that we are using through these MCP servers. And these tools are connected to the agents that we have. So, okay. And we also have observability, but I really want to show you the application right now. So if you go to this itinerary agent.deepset.ai, you will see a UI like this, but first you need to connect it to your GitHub because this is how OpenWeb UI works. And then we already have some prompts ready for you, just for you to try. And maybe we can try this one. I don't know about the internet here, so I didn't want to trust on that. That's why I ran this query already. So basically what it does is so here I say, plan a 2-day weekend trip to Barcelona, focusing on architecture and tapas. I prefer central 4-star hotels, have a moderate budget, and we will be traveling by public transport. I want to visit Sagrada Familia, Park Güell, and blah, blah. So you can also go very detailed with the prompt. And you see here there were some tool calls. So it asked Perplexity about what are the most significant architectural highlights in Barcelona for 2-day itinerary. And then it asked the accommodation strategy optimizer, optimize accommodation strategy for 2-day route in Barcelona by giving some of the highlights in Barcelona. And by basically running all these tools and these sub-agents that I previously showed you, you'll see this response coming from your agent. And the good thing is, if you think something is off, or I mean, you should always be doing that. We also connected observability to our agent, so you can see actually what each agent, so every input coming to an agent and every output coming out of your agent and every tool call and how long these tool calls took and how much money you spend on the tokens for each of these tool calls. You'll be able to see all of that in this observability tool that we have. So, for example, here I see that what are the best neighborhoods to stay in central Barcelona. It was asked to Perplexity, and Perplexity responded as, okay, you need to click some buttons here. And here, for example, it gives you some information and why these neighborhoods. So basically, you'll be able to see everything that happened in the agent, but you don't have to show it to your user, although your user will be able to see some of the details here. All right, so this is the observability part, because sometimes you need to debug a wrong answer. Maybe your user complains that, oh, like I get this answer, but it's completely irrelevant. What happened there? So you need to be able to triage that. Or sometimes there are some hallucinations happening. Maybe it seems like places in Barcelona, but no, maybe these are the places in Porto, but your LLM kind of mixed stuff up in the process. So observability is quite necessary for that. So these are like the videos that I put there just in case I won't be able to show you the demo. And let's look at the code of it. So this is the LLM part of the code. I mean, LLM is definitely the brain of the whole system, right? And you can choose multiple LLMs. So you can say that, oh, I want this agent to be run with this LLM, but I want this agent to be run this LLM. So you can design your system in whatever way you want. And you can also choose your model provider. So Haystack is quite model agnostic. You can choose OpenAI chat generator and use OpenAI models. You can choose Anthropic chat generator, use Claude, or if you want to host your model locally, you can use VLLM chat generator if you want to get models from Hugging Face, for example, Qwen or DeepSeek. So there is a long list of model providers and models that you can use already integrated with Haystack. So for this demo, we chose OpenAI chat generator GPT-5 Mini. And then the tools. So if you remember the agent architecture that I showed you, there were 3 MCP servers, and here with the MCP toolset, I connect to all of these servers one by one. So I connect to Google Maps, I connect to this optimal route server that we implemented, and I connect to Perplexity. And one thing that I do here, I specify the tools. So if you directly connect to an MCP server, it means that you will be fetching every tool that it has in the MCP server. I mean, I see some nods, and that's not a good thing. And there are multiple reasons for that. First, if there are like more than 100 tools with their tool descriptions, you will be putting all of this context into your agent, and your context will be sent to your agent every time you ask something, which means tokens, which means your context limit is already full with the tool definition, so you don't want that. And the other problem is, since you don't have the control of these MCP servers unless you're hosting them yourself, every time there's a new tool introduced, you have no idea what this tool is doing. Maybe it's something malicious, and we have been hearing about these supply chain attacks in AI world recently, so you don't want to expose your system to a tool that you have no idea what it's doing. So that's why it's always a good practice to specify the tool names, even if you are connecting to an MCP server. And then after connecting to all these MCP servers, I combine them as all tools, and I also put them into this searchable tool set. And what this one does is basically it provides the BM25 search capability for progressive discovery for my agent. And it means that although my agent has access to all of these tools that I introduced here, I'm not providing all of these tool definitions to my agent all the time. So when my agent thinks that, oh, it needs a tool to resolve this query, then it goes and looks at the list of tools that it has access to, makes a search there, and then only pick the relevant ones and put it into the context. So with that, I also save from the token a lot. And here's the sub-agents part of it. So we initialize these tools, and now I'm creating these sub-agents. And for every agent here, I provide a system prompt, I provide a chat generator, so basically an LLM, and I provide a list of tools. So this tool set is tool, the list of tools that I just created. And then after creating my agent, I pass it as a component tool. I create a component tool object with that agent, and I only passed the last message. So what does it mean? So if your agent, if you want to have a sub-agentic system, there are multiple reasons for that. The first one is you don't want to expose every information that the sub-agent has to your main agent. Because majority of the things for this agent resolving, you don't need them. You only need the last message, the last thing that your agent returns to be passed to the main agent. That's why I'm saying that don't give me the whole conversation that you are having with these tools, just give me the last message. Again, I'm saving from the context a lot here. And it's not just the cost that I'm worrying when I'm passing the last message, it's also when the context is so bloated, my agent also, my main agent gets really confused. So I'm also performing here, getting a very high performance. And then I'm creating the other agent in the same way. I pass, after creating my agent with the LLM toolset and with the system message, I pass it to my component tool with the name, description, and then the tool parameters, etc. are handled by these component tools. Okay, and then the guardrail part. So I want to show you here two examples. When you want to implement a guardrail, depending on your system, maybe you just want to make sure that, oh, like there are no prompt injections, or, I mean, maybe like my user cannot get information about like how to create like bonds from the system, etc. So maybe these are like some general checks. But at the same time, maybe you want to check some relevancy. So we said that this is an itinerary agent, so it's for travel, and I don't want my users to use this tool for, I don't know, like write me a story of like 1,000 pages about Shakespeare, etc. So this is completely irrelevant query for me. So the two ways you can do that, you can just pick an LLM and give a very detailed instruction saying that, oh, you are like an assistant for travel, so you can only you can only answer questions about travel, and I can also say that, oh, like the user can only ask for 10 days maximum, so they cannot plan, I don't know, 10 years of travel. That's important. And the other one is maybe for cost savings, I say like maximum locations per trip is 7, because otherwise then you need to plan, I don't know, like 14 different things at the same time. It's gonna take a lot of time and a lot of cost. So you might be giving, you might want to give a prompt to another LLM before you pass this user query to your agent. Or you might be getting very you might be doing something very simple by picking a guardrail model. There are so many out there. You can find some of them on Ollama. IBM has really good ones. There are really good open source ones, and NVIDIA Llama 3.5 NemoGuard is one of them. And it can do some topic control, meaning that if you say that, oh, you're a travel agent and don't answer any questions other than travel, it can classify the query saying that this is on topic or off topic. So based on that, you can just like ignore the off topic queries and just return a very generic message saying that, oh, this is definitely off topic for me, I'm a travel agent. Or if it's on topic, then you'll pass it to your agent. And this is the last code that you need for the agent. So basically, if you want to incorporate observability, you need to put a length fuse connector here with some credentials, or maybe you want to use other tools out there. There is like Arise, weights and biases, there's OPEX, so there are many of them if you're looking for open source as well. And then you define your itinerary agent. So basically you provide all the tools that you have and these sub-agents, stay tool and lodging tool. And then when there's a user query coming, plan me a trip of blah, 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 your agent will be able to solve the query. So let's look at the things that we did to implement this agent. So basically we looked for optimal autonomy. So I mentioned this before, you don't have to choose it's going to be an AI agent or AI pipeline. You can find something in between. Maybe a part of your maybe you start with a pipeline, but a part of your pipeline is an agent, so that you have the most optimal level of autonomy. You need to minimize the tools. So basically, if you are connecting to an MCP servers, maybe just give a list of tools instead of connecting all tools. Or even on top of that, you can say that, oh, let's do a dynamic discovery here. I'm not going to even pass the list of tools to you just yet. Just grab them when you need them with BM25. The other thing that you can do, multi-agent system. So basically, splitting tasks between specialized agents will save you cost, but at the same time improve the performance. Make sure that you have fat tools, so you need to try to encapsulate the logic and retries and fallbacks in the tool logic. Don't send this information to your agent. And the other one is guardrails and observability. You see that we had this link fuse tool, and we also checked the relevance of the query coming. And these are especially important if you have a customer-facing application. And the last one is human in the loop. So if you are working in a highly regulated environment like healthcare, or if you give your agent an access to read your data, write your database, so change something in your system, then ensuring that there are some people looking at this agent's activity and approving that when it's necessary is crucial here. And if you are curious to learn more, we have more content around how to implement like human in the loop with Haystack, how to incorporate memory, persistent memory, how to implement AI guardrails and safety, and also implement how to implement multi-agentic systems. And if you are interested in context engineering and how to get this optimal context for your system, we just published a blog post around that, explaining you what you need to do and some of the tips. And with that, thank you for listening. And you can scan this QR code if you want to get access to the presentation, or if you have any questions or comments around Haystack or around this presentation. And we are about to hit 25,000 stars on GitHub. I think we are missing like 40 people or something. So if you want to be one of our stargazers, I will be very happy on this very lovely Friday evening. And if you want to also try the itinerary agent, here is the URL. All right, thank you so much.